All right, let's jump right in. We're going to tackle 4 of the biggest, most mind-bending questions in modern physics today. You know, the kind of stuff that keeps even the experts up at night. And we're going to do it by looking at a really fascinating source that puts the standard view head-to-head with a pretty radical new perspective. So let's get into it.
So first up, let's talk about the heart of Einstein's general relativity. We've all heard it, right? Matter and energy tell space-time how to curve, and that curvature is what we feel is gravity. But here's the thing. Einstein's equations are incredible at telling us what happens, but they're completely silent on how it happens. What's the actual physical mechanism? How does a bit of energy reach out and literally bend the universe?
And you know what the honest-to-goodness answer from mainstream physics is? We don't really know. I mean, think about it. The equations are genius, no doubt. They predict things with insane accuracy. But they don't give us the how. Our source puts it perfectly. It's like having a recipe that gives you a Michelin star dish every single time, but it has no instructions, no cooking method, just ingredients and the final product.
So, to try and fill in those blanks, the source material we're looking at sets up this incredible dialogue between the established view and, well, a really challenging alternative. And just to be clear, we're not here to take sides. Our job is just to lay out this conversation for you. You've got standard physics on one side and this really out there, radical new idea on the other.
Okay, so let's dig into that first big question. We're calling it the energy space-time puzzle.
Yeah, let's break it down even simpler. How does one thing, energy, communicate with a totally different thing, space-time, and tell it to bend? I mean, what is that? Is it a push? Is it some kind of field, an exchange of particles? What's the actual interaction?
Okay, and this slide just lays out the 2 arguments perfectly. On the left, you have the standard physicist's view. Look, the equations work, but we admit the underlying machinery, it's incomplete. The how is missing. But then, look at the right. The changing space view says something, well, kind of crazy. It says there is no interaction. Why? Because they aren't 2 separate things to begin with. Get this, energy is changing space. The only reason we see them as separate is because of our limited human perspective.
And that brings us to the key concept here, this new term, changing space, or C-space for short. Now, according to this new perspective, C-space is the one fundamental thing. It's the bedrock of reality. Everything else we think is fundamental, particles, energy, you name it, is just a different form, a different manifestation of this one single dynamic thing.
All right, let's move on to our second huge question, and you'll see how this C-space idea starts to build. We're talking about the dark matter dilemma. You've probably heard about this one. For decades, astronomers have been scratching their heads because galaxies are spinning way too fast to hold themselves together. Something with a ton of gravity is out there, but we absolutely cannot see it.
And this whole mystery has basically split the physics community right down the middle. Are we on a hunt for some brand new invisible particle we just haven't found yet? Or is it possible our entire theory of gravity is just wrong when you get to these massive cosmic scales?
And here we go again. You can see the same fascinating split in thinking. On the left, the mainstream view is basically 2 camps arguing with each other. It's a particle. No, we need to modify gravity. But the changing space view, over on the right, kinda says, hey, you're both missing the forest for the trees. It argues we don't need to invent a new particle and we don't need to just patch up our equations. We just need to realize that space itself is way more active, way more dynamic than Einstein's original model ever assumed.
Now, probably the weirdest, most compelling piece of evidence we have for dark matter comes from watching entire galaxy clusters collide. It's amazing. So you have these 2 massive clusters approaching each other. They're giant clouds of gas. They smash together, they heat up, they slow way down. But the stars themselves, and, critically, whatever is causing that dark matter gravity, they just pass right through each other, like ghosts. It's bizarre. How does that even happen?
Well, the changing space theory has this really elegant, almost poetic explanation for this. It says, look, what you're calling dark matter isn't a cloud of particles at all. It's just the gravitational effect of huge, long wavelength waves, ripples in space itself. And think about it. What happens when 2 big waves in the ocean meet? They pass right through each other. They don't smash and stick. So it's not a collision of stuff, it's just waves passing through one another. Okay, so for our third question, we're going to challenge something so fundamental, we don't even think about it. We're going to rethink time itself.
You know, one of Einstein's greatest achievements was merging space and time into this unified, four-dimensional thing called spacetime. In relativity, they're basically on the same team, treated as equals. But what if that's not right? What if that's not how reality actually works?
So, the standard model on the left is clear. Space and time are two sides of the same coin, inseparable. But the changing space view makes a truly radical claim. It says, nope, space is all there is. Time, in this view, isn't a real physical dimension you can move through. It's just a concept. It's a tool we humans invented to measure the rate at which space changes.
Okay, so we've looked at three massive nagging puzzles in physics. Now let's pull it all together and see how this one theory, changing space, attempts to create a single, elegant framework that might just explain all of them. And this is really the core appeal of the changing space idea from our source. It takes these huge, separate mysteries that all seem to need their own unique solutions, and it reframes them. It says these aren't three different problems. They're three different symptoms of the same fundamental misunderstanding. In this view, energy, dark matter, and time all just boil down to different aspects of one thing, a dynamic, constantly changing space. And that leaves us with one last really deep question to chew on. Are the laws of physics we've discovered describing reality as it actually is? Or are they just incredibly powerful descriptions of reality as we, with our limited human minds, are able to perceive it? This whole changing space idea really forces you to question the line between reality and our model of it.